do it.
Speaking of which, I had forgotten to start the recording. Yeah, I just started it now. Yeah. It's your guys' job to remind me to record it. It's for you, not for me.
You have like similar classes in the last
I don't know. All right. So, anybody in here have a suggestion?
I mean, I thought of something
Okay, what?
may or may not work. I said for I in range 0 to length self dot list of inhabitants, if self dot list of inhabitants, if bucket I does not equal the inhabitant, print the inhabitant does not exist in the break.
Well, that's only going to find out if it doesn't exist in that one bucket.
Okay, that's true.
Yeah, where we want to know, we're really asking the question, did I remove something from my list?
Okay.
So one thing I can do is I can say something like orig length is equal to the length of self dot list of inhabitants. And then I can say if orig length is equal to length of self dot list of inhabitants. If that's a true statement, second parenthesis here, then we could say we did not remove anything. Else, we did remove the inhabitant. Does that make sense? So I can ask about the length of our list afterwards. If I remove something from this list and the list now has a different length than it did before, if I tried to remove something from this list and my list has a different length than it had before, that means whatever I tried to remove, I did remove. But if it still has the same length, I didn't actually remove anything. Make sense? Okay. Another thing we could have done here is we could have maybe said temp is equal to none. And this would have been probably harder for you to come up with since I had just shown you how pop works just a few minutes ago. We can say temp is equal to whatever we pop because pop actually removes it and returns it. So we get the value from it. So then I could have asked the question, if temp not equal to none, we remove something. Else, we did not remove anything. So either one of these could have been a way for us to find out if we removed something from the list or not. Make sense? All right, and this gives us more control than calling that remove function, because that remove function is going to either do its job and remove it, or it's going to crash. And we could use a try catch to pull that off, but we're not going to right now. So we're going to go off of this approach. I'm going to go ahead and use the length difference. I think that's kind of in our wheelhouse, because remember, we're basically puzzle solvers in here. We're getting better and better at solving these puzzles, and we have to solve all these puzzles in terms of the tools we have available to us. Okay, pop was just something we were introduced to, right? Just something we were introduced to. So we don't necessarily have a strong feeling on how that guy actually works. So, I mean, I could have actually avoided using pop here. I could have actually called remove, right? I could have said dot remove the inhabitant like that, and then still break. The length will be different, right? But I already knew about remove before. But because we've done it inside this if statement, we know for a fact that this won't fail. Remove only fails if the thing I'm trying to remove wasn't there. I know it was there because I asked about it. Make sense? Okay, so we still could have used remove, but I think pop is a useful enough tool here. So let's keep pop going there. But in terms of us as problem solvers using our tools we have available to us, we certainly know how to ask about the length of a list. We certainly know how to remember the original length of the list, right? This code right here basically captures our nuts and bolts of programming. Remember, repetition, asking questions. Make sense? You have a question?
No.
Okay. All right, so when we try to remove the inhabitant, we'll remember the original length of our list. We'll go through and we'll try to remove the inhabitant. Then we'll say, is my list length the same as it was before? If it was, we didn't remove anybody. So maybe I'll do like a little print. Nobody here like that. Something like that. Just a placeholder error feedback type thing. Maybe even just so when you think about this from the perspective of MUDs, when you have messages that are meaningful, maybe you want to flag them in some way. That way your eyes catch it, something like that. It really was shocking how they still exist. MUD still exists. You can go and play one. So if any of you want to say, I want to know what it was like, go and look up, like what's the most popular MUD out there today. Now they have these nice, applications that allow you to connect to the MUD, and they give you some color coding, and they even give you like a map, where it remembers where you've been, so you can kind of visualize it a little bit more. So they've made it a little bit easier for you, but it was, I don't know, I think you'll be surprised how immersive something text-based can actually be. And it's something that a lot of you at your age were never exposed to. All right, so if the length is the same, we haven't done anything. Otherwise, we did remove an inhabitant. So if we removed an inhabitant from this room, that was our job, right? He's removed. So we're going to go ahead, and when we say remove inhabitant, I'm going to have this guy return a value of true or false now. So I'm going to say nobody here like that, and then I'm going to say return false. Else, return true. The inhabitant you asked me to remove, let's go up and put a little comment before this function. We'll say, try to remove the inhabitant from the list and return true if successful, and false if unsuccessful. Okay, that way somebody else can now use this function and say, remove this inhabitant, and then I can check to see, did it work? If it worked, that means I removed the inhabitant from the current room. I can now safely add them to another room. Because what we don't want to do is we don't want to have a situation where I say, remove this inhabitant from this room. I didn't actually remove it. And then I put this nothingness into the ether somewhere. And I try to add nothingness to my next room. All right. So remove inhabitant will do its job. And we know that we have access to this inhabitant from somewhere else because we passed it in here. So we will attempt to remove the inhabitant and get a true or false on whether or not it happened. Okay, so are there questions about what this code is doing right here? I actually would say that if you look at just this nugget of code and you study this some and make sure you fully understand what this code is doing, that's a pretty good capture of what we should be confident with doing in this class so far. Not necessarily saying that you could have just sat down and written this in 2 minutes. You would have to think through it a little bit, maybe do some experimentation or something like that. But when you see it written, you should be like, oh, this makes some sense to me. Okay? So that's our remove inhabitant. Now, what about add inhabitant? When we add an inhabitant to a room, we're no longer, well, here, I skipped the method here because we didn't need to do anything here. So add exit, that's nothing I need to update for me switching the mentality of a room from storing a single inhabitant to storing a list of inhabitants, right? That's what we're really doing here. We're upgrading our program to support lists of inhabitants in a room rather than a single inhabitant in a room. Okay, so I don't need to change anything with add exit. That was part of our kind of world building portion of this. All right, so now add inhabitant though. When I add an inhabitant to a room, I am not setting the current inhabitant of this room equal to that inhabitant. Instead, I'm going to say self dot list of inhabitants dot add an inhabitant. I'm adding that guy to this list. But now I will then tell that inhabitant. Notice here, before it used to say this. It used to say self.current inhabitant.current room, because two things happen. When I add an inhabitant to a room, the room becomes aware of that inhabitant, and then we let that inhabitant know about the current room they're in. Those are the two things that happen. All inhabitants know about their current room. So I'll add them to my list, and then I can't say self.current inhabitant because that variable's gone now. So he's actually called an inhabitant right here. So I'll say an inhabitant, because he's not self.inhabitant, he's a local variable here to this function. So an inhabitant dot current room. This is an inhabitant's current room is going to be equal to this particular room. Good.
In your self dot list of inhabitants dot add an inhabitant, is that supposed to be a pen?
Possibly. Can you not add something directly to a?
I've never used it.
That's possible.
I have no idea.
It's not, no, well, you do have an idea. You work with Python a lot more than I do.
Well, I've never heard of it.
Let's find out. So there's my list. Can I add something to a list? You're right. You definitely can append something to a list. I'm more interested. Can you also add to a list? You can. So list dot append 5. So now I can say list, and there's my 5. Okay. Yep. Oh, there it is right there.
Down a little bit.
Yeah, I know.
Oh yeah.
I even had a cheat sheet, is what I'm saying. All right. Well, all right. So yeah, but there's your example. So you knew the answer, right? You were wondering if add was a thing that worked. But keep in mind, so I mean, this just goes back to that something I said like day 1 or 2 of class is that all programming languages are the same. Programming is the skill set. The language doesn't make a difference, right? So, you know, today I teach this class in Python, the next class in Java, the next class after that in Scheme. So I'm working in 3 different programming languages today, but I'm using the same logic things. But then you sometimes get situations like that where I'm like, well, to add something to an array list in Java, you call the add function. See what I'm saying? So you got those little idiosyncrasies. Like a function is called this in this language, it's called something else in this language, but it's still, you're adding something to a collection. So those are the things you'll run into. You know, when you spend all day long writing in a certain language, you don't make those things. But we'll just say I did that on purpose. But it's evidence of that programming is not the difficulty here. It was clear what I was trying to do, right? I was just using the wrong function. So yeah, good catch. All right, so I'm going to append that list of inhabitants, the inhabitant, but then I'm going to let that inhabitant know that the room he's currently in is this room, self. So self right here, remember, self is how an object refers to itself from within itself. I am currently inside of a room object. So when I say self, I am talking about this room, the room that we're currently in. And I'm going to let that inhabitant that I just added to my list of inhabitants, I'm going to let him know that the room he's in, I guess I'm going to give him a little piece of my soul. So I'm really giving him the memory address where I live. This is the room you're currently inhabiting. All right. So that's add inhabitant. All right. Well, one was this guy up here was remove inhabitant, and he took in the inhabitant we were removing. The other one, so I think this was left over from when we were starting to make a transition. So the other one, this guy just says, oh, we assume we only have one inhabitant, so let's remove that single inhabitant, right? We no longer have that. So we'll just go ahead and dump that function because we have a better version of it now. Okay. Just real quick, let me just make sure. This guy just set current inhabitant to temp, and then we remove temp. Yeah, that's fine. We don't need that. Okay. So that's that guy. Find exit, we don't need to make any changes there. That's dealing with the world construction, right? Display, we're going to say room name. We're going to go through all of our exits. But then this part we do need to update because we don't want to say just one inhabitant, right? We don't have a current inhabitant name. So now we need to go through all of the inhabitants in this list and build up probably a string of those inhabitants' names. Okay, so what we're going to do is before, in fact, what I'll do here is I'm going to put a little comment here. So go through all of the inhabitants in this room and build a string that is the name of all of those inhabitants separated by spaces, let's say. Okay, so take a minute and try to write the code that will go through the list of inhabitants for this room and build a string and what we'll actually print out here is the inhabitant string. So this is what will ultimately print out, but we're going to have to build this string here. So take a couple of minutes and try to write the code that accomplishes this single task, going through our list of inhabitants and building up a string of all the names. Go ahead. Yeah, but you could have an extra space at the end. It's not the end of the world. But yeah. He was asking, is the way to get rid of an extra space at the end to use the strip function? And the answer is yes. But on the screen, we're not going to see that extra space, so it's not the end of the world. Give me about 1 more minute. All right, so let's take a look at this. We're going to go ahead and create, we're going to remember something. What are we going to remember? An inhabitant string, and we're going to start that off as the empty string. We're going to go through all of our inhabitants. So for an inhabitant in self.list of inhabitants, we'll say inhabitant string is equal to inhabitant string concatenated with an inhabitant dot name, the name of that inhabitant, concatenated with a little space afterwards. Okay, and then we'll go ahead and print out the also here thing. Here, this is who else is here, whatever the inhabitant string shows. If there's nobody else in there, then, well, actually, technically right now, it'll also show us. So there should be at least one person in there. It's going to be us. We might choose to omit ourselves from this. So we might say, so as this stands right now, we're going to go through all of the inhabitants in this room, including us, and build up a string that has all of their names. What if I only add the name to the list or to the string if they are not us? Right now, display for a room takes in it doesn't take in any parameters, right? So it doesn't know necessarily who's calling display. They don't know the player this is being displayed to. So what we might say is we want to say, when you call display on this, give me the context in which it's being displayed. Whose screen is this being displayed to? So we might say here, the inhabitant. That's whose screen is going to be displayed towards. So then down here in display, when we go through here, we're going to say if an inhabitant is not equal to the inhabitant. If that's a true statement, then we'll go ahead and add them to the string. This is saying if this object, that is an inhabitant, is the current object from my list of inhabitants, if that is a different object than the person who called this display method, that's what we're saying here, right? The inhabitant is the parameter that we passed into display. We're adding a parameter to display. Whenever we ask a room to display itself, we are telling them who they are displaying it to, so that we make sure that that room does not display that person's name under the also here list. Because otherwise, from your perspective, it might be like I see a clone, right? I walk into the room and say, oh, who else is here? Okay, and I see a couple of students as well as myself. That's who else is here. I might not consider myself to be on that. I might not want myself to be on that list. Make some sense? Okay. But now keep in mind, since we updated this display function, all the other places in our program where we call that display function, we now need to make sure we give it an inhabitant that we would be displaying it to. Now we might say, oh, well, for right now, won't that just always be us, the player? Sure, but what if we are moving down the line a little bit? We probably won't do this in here. But what if we're moving down the line a little bit and we get to the point where we're like, hey, I want this to be a multi-user game. You know, we got 20 people connected to this. And if Ben is in the room and he is asking the room to display itself, he wants to see everybody else that's here except Ben. If I am in this room and I call and I see display, I want to see everybody here except for Mike. Make some sense? So that's why we're updating display to take in the name of, well, take in the entire inhabitant that is interested in having the room displayed to themselves. Keep in mind here that this tool is something we are inventing. We are deciding that this is how it's going to work. You can just as easily make an argument here and say, well, I'm not going to pass in the inhabitant. And you know what? I'm just going to show them everybody who's in this room, including themselves. That's a reasonable enough argument, right? What's the reason we're doing this is because we're at the point now where we can add a little bit more complexity to our solutions because we're getting better and better at programming. So this allows us to introduce a little bit more problem solving. So understand now that this display function is a tool that we can call upon. But whenever we call this guy, we now need to pass it the inhabitant that this is being displayed towards. Okay, so that's our room. Dice isn't going to make any difference. Let's see, deathmatch. We have our players, they fight each other, has nothing to do with rooms. Here's an inhabitant. An inhabitant does know about their current room, and we're handling that now. They have roll stats, was successful, take damage, blah, blah, blah. Okay, then we have our NPC and our player. Those guys are just inhabitants, a little bit more. Then we have our exits. Nothing special about exits from our, really what I'm doing is I'm looking for where have I used my things that I just changed and what do I need to now go and fix? All right, so here's my constructor for rooms. These guys are all okay. Let's see, we have a chat. You made a map for the original, not the whole game, Cody, I hope. Well, actually, I hope you did. Are you talking about the original world map or like Dungeon 1 in Zelda with the little dragon guy at the end? Actually, I guess they all have the dragon guy at the end. All right, so we're creating our rooms. Oh, on the screen, do you not get to see the chat? It's possible if you're online, I'm sharing it, you don't get to see the chat. Cody said he made a map of the original Zelda game instead of computer science. How many of you played the original Zelda game on the original Nintendo? That's not the original. Ocarina of Time is like Zelda 6 or 7. No. The original Zelda was the only Nintendo game that had a gold cartridge. So you played Super Mario Brothers 3 on the original Nintendo. That's what you said you played? Yeah. That's not bad, because at least you played on the original Nintendo. Now we're talking original Nintendo, not like the released Nintendo Classic thing.
Didn't the Nintendo World Champions cartridge have a gold cartridge?
It's possible. It's possible it did.
Yeah, it did.
I played Super Mario Brothers 3 in the arcade.
It was an arcade, I think?
Yep. big machine.
Oh, no, I think that was when I was like 4.
See, I think Super Mario Brothers 3 must have come out when I was I don't know, 10, 11, 12, something like that. I also played the original Mortal Kombat in the arcade. Original Killer Instinct in the arcade. Like, what's an arcade? That's where your parents dropped you off at the mall when they went shopping. That's what an arcade was.
I just watched one the other day. I was thinking, oh, this was like COVID infested probably, but
Oh, everybody touching all the controls?
yeah, they had hand sanitizer everywhere though, I guess.
All right. So we're creating a bunch of rooms. Nothing's changed there. We're adding some exits to rooms. Nothing's changed there. We're taking our inhabitant. We have two different inhabitants, right? Really, this shouldn't be an inhabitant. This should be a player. Then we're taking our room. We're adding our inhabitants to that room, which we tried to do earlier, and only the last guy stuck, right? Okay, but now we should have both of them in that room because add inhabitant we've updated to be able to show the current inhabitant. Okay, now here inside of our loop, we're saying the inhabitant, whoever the current inhabitant is, which is our player, we want the current room, so the current room they're in, that's the room the player's in, to display itself. But now this display function is expecting an extra parameter from us. They want to know, who am I displaying to so I can leave their name off of the also here. So I'll go ahead and do that. All right, and the rest of that should be good, I think. So notice here, shows our room, exit north leading to hallway. Also here is the rat, not us and the rat. Okay, so we can go north. Let's see.
You gotta work with the exits.
Yeah, so remove inhabitant, missing one required positional argument. So that is line 144 for take exit. All right, take exit when we remove the inhabitant from a current room, and then we add an inhabitant to a destination room. Why is that a... Let's look at add inhabitant. That looks okay to me. When we add an inhabitant to a room, for that we call remove inhabitant. We remember the original length. We go through every element. Good.
The remove inhabitant function and take exit needs to take in the inhabitant.
Okay, we'll check that in a second. Let's just look at remove inhabitant here. So it takes in an inhabitant, we get the original length, we go through all of our list of inhabitants, we ask, is the current inhabitant the guy we want to remove? If it is, we'll pop him and break. If the original length is equal to the, oh, really it's the, well, this shouldn't be a problem since we know anybody we're removing should be there, but because we're not using the false and true that's coming out of here. So if original length is equal to the length of inhabitants, that means that we didn't find them. Return false, we didn't remove them, otherwise return true. All right, right, so here's our exit. Take exit takes in an inhabitant. Oh, when we call remove inhabitant, we need to pass it the inhabitant. Because no longer does a remove inhabitant just remove the inhabitant of the room, the single inhabitant of the room. Now they need to know, who am I removing from the list? And then we'll add them to inhabitant there. What's this?
Dot name.
For which?
Right there, right after inhabitant.
Here?
Yeah.
No, because remove inhabitant should take in an actual inhabitant, not the name of the inhabitant.
But it's gonna print that we remove it.
Remove, where are you talking about? Remove inhabitant takes in an inhabitant object, not just that guy's name.
No, I know that, but it's gonna try and print it, because then if I remove inhabitant, it print if it's removed. Oh, I printed if it's removed, you don't.
Okay.
So you don't need it, I did.
All right, so I made my guy go north, and now the rat's not there. I'll make him go south. Rat's still there. All right, so now our guys are, moving around, and we have lists of inhabitants in the room. Now, if we wanted to, let's just look at a little code hacking-y type thing here. What if I wanted it to show myself in the room? What could I do to this line right here so that when I am displaying the room, it also showed my name, not just the rat, for example? That line I have highlighted right there. If I want it to display when it displays the room, I want it to show me and the rat, not just the rat's name. What can I hack on this line without going and changing how display works? What can I change on this line so that it will show both my name and the rat's name? Go ahead.
You put a tuple and then the name of the variable for the rat inside the display.
Well, what is this guy? I can't change display. That's against the rules. I can only change what I have highlighted here.
And then you only accept one parameter.
Accepts one parameter, and it expects me to pass it an inhabitant. And what does it do with that inhabitant? It checks as I go through my list of inhabitants, it checks to see if the inhabitant I'm currently looking at is equal to that guy. So that guy is me right now, right? And so that means it's not going to show me on the screen. That's why it just shows also here is a rat. I want to see also here is Mike followed by a rat. Mike space rat. Or rat space Mike, whichever order it ends up being in.
So just redo what we had before.
Can't change the code. You can only change this one line.
Okay.
It comes down to what kind of animal is this? This is an object, an instance of an object. And instances of objects are stored as memory addresses. So when we ask the question, is the current inhabitant I'm looking at in my list equal to the inhabitant I'm passing in? Really what I'm saying is are their memory addresses the same? How can I say the memory address that points to nothingness? I can say none here. And now I get Mike and the rat. I am passing it. I'm saying display relative to nobody. Relative to nobody. This is the inhabitant that doesn't exist. You will never find a match of this guy in your list of inhabitants. Make sense? Okay. Not that we want that, but just kind of this goes back to that idea of passing something by value versus passing something by reference. Objects, just like lists, just like dictionaries, are passed by reference. So changes that we make to those guys are would be permanent. They'd be noticed outside of there. In this case, when I call display, I'm expected to pass it the inhabitant who is asking the room to be displayed so that we can omit his name from the list of also here. But if I pass in none, I say, look, just display everybody. I'm giving you basically an empty memory address so that you don't find a match for this guy in there, and you'll show me everybody who's in the room. So I get the Mike and the rat. But more than likely, you'll want to show everybody else that's in the room besides you. Okay, so for your homework, add another command besides just taking exits that allows a player to attack another inhabitant in the room and creates a death match between them. So for example, I should be able to say, kill rat from the first room, and then a death match between Mike and the rat would occur, where someone will die. That makes sense? Right now, we are assuming any command we give is an exit, north, south, east, west. So now we need to check for an additional kind of command where we say kill. If we type in kill, followed by the name of something we want to kill, we're going to search through that list of inhabitants, find the guy who has that name, and then enter into a death match with him. Otherwise, if we don't say kill followed by a name, we're going to assume it's an exit. Make sense what I'm asking you to do? All right, I'll give you the current version of the code on Slack. And I will see everybody on Tuesday. Favorite game on Nintendo 64, Cody, was Killer Instinct. I played that in the arcades as well. That was the whole reason to get that.